Hello students, in today's video I will be discussing structure of glucose with you. So without wasting any time, let's dive straight into today's topic and explore the structure of glucose. Glucose is an aldohexose and is also known as dextrose. It is the monomer of many of the larger carbohydrates, namely starch, cellulose. It is probably the most abundant organic compound on Earth. It was assigned the structure given on the basis of the following evidences. Number one, its molecular formula was found to be C6H12O6. Number two, on prolonged heating with HI, it forms N-hexane, suggesting that all the six carbon atoms are linked in a straight chain. Number three, glucose reacts with hydroxylamine to form an oxime and adds a molecule of hydrogen cyanide to give cyanohydrin. These reactions confirm the presence of a carbonyl group, CO group, in glucose. Number 4. Glucose gets oxidized to 6-carbon carboxylic acid, gluconic acid, on reaction with a mild oxidizing agent like bromine water. This indicates that the carbonyl group is present as an aldehydic group. Number 5. Acetylation of glucose with acetic anhydride gives glucose pentaacetate, which confirms the presence of 5 single bond OH groups since it exists as a stable compound. 5 single bond OH groups should be attached to different carbon atoms. Number 6. On oxidation with nitric acid, glucose as well as gluconic acid yield a dicarboxylic acid, saccharic acid. This indicates the presence of a primary alcoholic single bond OH group in glucose. The exact spatial arrangement of different single bond OH groups was given by Fischer after studying many other properties. Its configuration is correctly represented as first. So gluconic acid is represented as second and saccharic acid as third. Glucose is correctly named as D plus glucose. D before the name of glucose represents the configuration, whereas plus represents dextrorotatory nature of the molecule. It should be remembered that D and L have no relation with the optical activity of the compound. They are also not related to letter small d and small l. The meaning of D and L, capital D and capital L notation is as follows. The letters D, capital D or capital L before the name of any compound indicate the relative configuration of a particular stereoisomer of a compound with respect to configuration of some other compound, configuration of which is known in the case of carbohydrates. This refers to their relation with a particular isomer of glyceraldehyde. Glyceraldehyde contains one asymmetric carbon atom and exists in two enantiomeric forms as shown below. Plus isomer of glyceraldehyde has D configuration. It means that when its structural formula is written on paper following specific conventions which you will be study in higher classes, the single bond OH group lies on right hand side in the structure. All those compounds which can be chemically correlated to D plus isomer of glyceraldehyde are said to have the configuration, whereas those can be correlated to L minus isomer of glyceraldehyde are said to have L configuration. In L isomer, single bond OH group is on left hand side, as you can see in the structure. For assigning the configuration of monosaccharides, it is the lowest asymmetric carbon atom which is compared as in plus glucose, single bond OH on the lowest asymmetric carbon is on the right side, which is comparable to plus glyceraldehyde. So plus glucose is assigned D configuration. Other asymmetric carbon atoms of glucose are not considered for this comparison. Also, the structure of glucose and glyceraldehyde is written in a way that most oxidized carbon is at the top. Cyclic structure of glucose. The structure first of glucose explained most of its properties, but the following reactions and facts could not be explained by this structure. Number one, despite having the aldehyde group, glucose does not give Schiff test and it does not form the hydrogen sulfide addition product with NaHSO3. Number two, pentacetate of glucose does not react with hydroxylamine, indicating the absence of free single bond CHO group. Number three, glucose is found to exist in two different crystalline forms, which are named as alpha and beta. The alpha form of glucose melting point 419 Kelvin is obtained by crystallization from concentrated solution of glucose at 303 Kelvin, while the beta form melting point 423 Kelvin is obtained by crystallization from hot saturated solution at 371 Kelvin. This behavior could not be explained by the open chain structure. First, for glucose, it was proposed that one of the single bond OH groups may add to the single bond CHO group and form a cyclic hemiacetal structure. It was found that glucose forms a six-membered ring in which single bond OH at C5 is involved in ring formation. This explains the absence of single bond CHO group and also existence of glucose in two forms as shown below. These two cyclic forms exist in equilibrium with open chain structure. The two cyclic hemiacetal forms of glucose differ only in the configuration of the hydroxyl group at C1 called anomeric carbon, the aldehyde carbon before cyclization. Such isomers, that is alpha form and beta form, are called anomers. The six-membered cyclic structure of glucose is called pyranose structure, alpha or beta. In analogy with pyron, pyron is a cyclic organic compound with one oxygen atom and five carbon atoms in the ring. The cyclic structure of glucose is more correctly represented by Haworth structure as given below. So, students, you have just learned about the structure of glucose. If you enjoyed this video, please like, subscribe to and share the channel. Also leave a comment to get answer to your questions in the next video. That's all for now. See you in the next video.